Hello class. Okay, so we are doing section 1.2 now. And this section is all about exponents. Okay, so you have to learn all about exponents. So I assume you already know kind of the basics, right? You know that this is this power, right? That's what an exponent is. And we know how it works when it's just a number like this, right? This means 3 times 3 times 3 times 3, 4 times, right? And it's equal to 81. Okay. And right when we have stuff like this, -2 times -2 times -2 equals -8. Right? So, big deal though is notice parentheses. Okay, so I'm gonna do -2 to the 4. Right, and this is -2 times -2 times -2 times -2. And this is 16. Okay, right, because the negatives all cancel, right? Because this is 4 and this is 4, and that makes 16. That's different than this. Okay, -2 to the 4. Because when you do it like this, the order of operations says that this is a minus sign in front of 2 times 2 times 2 times 2. So this gets you -16. Okay? So big deal that you know the difference. Okay? And don't just assume the minus sign is inside when there's no parenthesis. Okay? All right. So, now we're going to go over something your book likes to call the laws of exponents. Okay, and so what these are is how exponents work in relation to each other. Okay, so if we have power and a different power, right? If we have two of the same bases, okay, A, and we're multiplying them, then you just add. Okay. And then if we have a fraction, so we have AM over AN, then you subtract. Okay, and the one on the bottom is the one with the minus sign. Okay. And actually, this right here is just canceling. Okay. So what do I mean? Like, look at this example, right? X cubed over x squared, right? Some of you would do it like this, right? You would write down 3x's and 2x's, and then these cancel and you get the answer, x to the power 1. But if we do this thing, you see that it's basically the same because you're going to get 3 minus 2, which is 1. And like, ta-da, it works. Okay? So this is just a fast way to cancel. All right. Now, let's go a little inception-y. Okay? We have a power and we're raising it to a power. Okay? This would be a to the m times n. Okay? And then you can see this if you actually like work out the example, right? So like 2 squared cubed. This is 2 squared times 2 squared times 2 squared. And if we do the adding rule, we can see that this is actually 2 to the power 6. Okay. So just like a shortcut. All right. And then kind of like a big deal, okay, is if you have stuff like this. This is AB times AB times AB, right? E n many times. Okay? Which is also equal to, right, if I like rearrange all of these, like I put the B's all on the left and I put the A's all on the right, it's A to power n, B to power n. So you can like distribute, kind of, okay? Now, this leads me into the number one mistake to not do. Okay? Do not ever do this. For a while, I just instantly gave people zeros if I saw this. Okay? A plus b to power n. Okay? You cannot distribute the power, okay, with a plus or a minus sign. Okay, not correct. Okay. If there's a plus or a minus sign, it does not work, okay? Because like right, like just kind of think about it, right? This is n and this is a thing, so you should be doing a plus b, a plus b, a plus b, right? And then that's like a whole bunch of foiling. Yes. Okay. So just, reminder, this is very wrong. Okay, do not write this down ever. Okay. There's an entire section on this. It's called the binomial theorem, and that's uh, maybe the last section we'll talk about in the entire class. Okay. But that's pretty much the exponent laws. Now I'm gonna go over some side facts. Okay. Anything to power 0 is 1, except 0. Okay, 0 to power 0 is an error, does not exist. Okay, try plugging it into your calculator. It will be mad at you. Okay, but anything to power 0 is 1. So yeah. Next thing, which this is really like the next section, but I'm just gonna do it now. Okay, is what is a negative exponent? Okay, I like to think of a negative exponent as like a flipping. Okay, so right, every single number you could do this, right? You could put a 1 here, right? I like to think of the negative exponent as you just flip it across and this becomes a plus 1 now. Okay, so like negative exponents really just mean flip across the fraction bar. Okay, so like example, -3 squared to the -2, my bad. That's 1 over -3 squared, and that's 1 over 9. Ta-da! Okay. And then, if you want to make it a little more complicated, okay, so like x to the -3, y to the -5, you can kind of like do it like one at a time, okay? And then flip the y. Okay. So like the flipping kind of happens independent of everything else. So if you wanted to go from here to here, you could skip this like middle step, okay? You could just flip stuff at will, okay? So, um, let's do some more examples of this. And this is also guaranteed to be on your test, okay? So usually I'll just give you like some mess, okay? And I'll just be like, simplify. Don't leave any negative exponents. Okay, so this thing. Well, we see, right? We see these are the things, right? These are the ones that have negative exponents. So really what I'm gonna do is I'm gonna leave the other ones alone. Okay, so these just stay where they are. And then I'm just gonna flip these accordingly. So the x squared goes on the bottom, the y cubed goes on top, and then this x plus 2 becomes x plus 2 to the positive 1, which we don't really write the 1 ever. So ta-da! This is what happens. Okay. So get a little comfortable with moving things around and leaving some stuff where it is. Okay. That's kind of the goal of pre-calc, is that you're comfortable doing algebra, okay, in messy situations. So, other examples will be like this. Y over 3z squared to the negative 2. Okay, so there's many ways to do this, and like no one way is correct. Okay, so first you could distribute the negative 2 to everything. Okay, hopefully correctly. And then, flip everything. So this will become a 9. This becomes z to the power 4, and this becomes y squared. Okay, but what you could do is you could like take the minus sign and distribute that on the inside, and this is a little fancy, but that just means flip the fraction, and now you have a squared, and then this becomes 9z to the 4th y squared. Okay, and if you see, they're equal. Okay, so there's many ways to simplify with exponents. Okay, as long as you know you're doing it correctly though, then it kind of doesn't matter. Okay, it's up to personal preference. All right, now technically in this section I believe we're supposed to talk about scientific notation, but for those of you that like care, you've probably learned it in your science classes, and for those of you that don't care, I am in the same boat, so we're just not going to talk about it. Okay, so moving on to radicals. Okay, so radicals are what we call these things, all right, like this symbol. Okay, so right, this is a square root. Okay, and so something I kind of want to tell you guys is that roots, okay, are exponents. Okay, like a root is an exponent. They are literally the same thing. Okay, so that means all of the exponent rules are also the radical rules. Okay, they all follow the same thing. So if I have square root of AB, that's square root of A, square root of B. Okay, now you got to be a little careful with pluses and minus signs when you do this. Okay, but for the most part, it just works. Okay, and so another thing is that a square root is this, and you can kind of imagine a 2 here, but we never write it. But a cube root, okay, is this. Okay, and the cube root of 8 is 2, because, all right, because 2 times 2 times 2 is 8, right? So you need something that multiplies to 8 if you multiply it with itself 3 times, okay? Also, this is the symbol for because, okay? All right, so you should just know a couple of these, okay? I hope all of you know like square root of 9 is 3, square root of 25 is 5, right? Cube root of 27 is 3. Okay, like a couple of these you should be able to figure out. Okay. The stuff inside square root should always be positive, or so we say the domain of square root of x is x positive. Okay. So what I mean is basically, right, square root of 9 is 3. Okay. But square root of negative 9, for right now, we're just going to say does not exist. Okay. In the future, we're allowed to know that it's plus minus 3i. But for right now, it doesn't exist. Okay. Okay. But this rule with minus signs only applies, okay, to even roots. Okay. So what do I mean? So like square root, fourth root, sixth root. Okay, if you have there, x needs to be positive. But if you have cube root, fifth root, seventh root, okay, so on and so forth. X can be real numbers. Okay, and an example is cube root of -8. Okay, that has an answer. And since we know cube root of 8, it's actually kind of simple, right? Because -2 times -2 is 4 times -2, that is -8. Okay? So yeah, so this is why with odd roots, you can have negatives because it works. Okay? But with even roots, the minus signs always cancel, and that's why you have a problem. Okay? So yeah, so very important distinction between the even and the odd. Okay? All right. Now, okay, we're going to talk about this thing. Okay, because this, okay, is kind of how we simplify. So for example, square root of 8. Okay, square root of 8, you should split up into 4 times 2. And then you split the square root like this, and you know that the square root of 4 is 2, and so square root of 8 is 2 root 2. Okay. The other way you were probably taught in like high school is you break it up like this, and you know that 2 go out, and this one stays in, right? That's the other way a lot of people learn it, okay? Same thing. But yeah, this is how you simplify roots, okay, is you kind of technically break them like this. Okay, now a huge deal, big deal, okay, is it works with fraction bars, because remember all of the exponent rules work with square roots, because square roots are exponents, okay? And so that should mean that this is obvious, that you cannot break a square root across a plus. Okay, this should be very clear that this is not okay. All right, so pluses and minuses, bad. Okay. All right, now, I kind of need to introduce complicated roots, okay? Because so far, right, like x squared means x times x. X to the -2 means 1 over x times x. What is x to the 1/2? That is square root of x, okay? And x to the 1/3 is cube root of x, okay? So roots are fractions, exponents, okay? That's why I said they are exponents, because they just are the fraction ones, okay? So we can have things like this, x to the 2/3. What does this mean? Well, it's kind of like you look at each part. So this means it's a cube root, okay? And this is the same as we always know, right? This just means it's x squared, okay? So when you have complicated fractions, this is one way to do it, okay? And you can do it the other direction because of like the commutivity. So if you wanted to do cube root of x squared, this is okay. These mean the same thing, okay? All right. So now let's do an example of a question that kind of could show up on your test. Okay, so 2a cubed b to the 4th to the 3 seconds power. I want to simplify this. Okay. So step 1 would be I distribute this to all of the powers. So 2 to the 3 seconds. A to the 3 times 3 over 2. Okay, I'm going to put the 1 there. And b 4 times 3 over 2. Okay, and then I'm going to figure that out. So what is this? Okay, this is the square root of 2 cubed. Here I'm going to have, right, I know how to multiply fractions. So this is 9 over 2. And b is going to be 12 over 2. Okay, that's actually just 6. Okay, so that's 2 root 2. Okay, hopefully we know. Right, this is square root of a to the 9th power, and this is b to the 6th. Okay, square root of a to the 9th power. I'm going to do this. Okay, so a to the 8th, 1. Okay, and then I'm showing kind of too much work. You guys do not need to show this much work if you do it. Okay. So right, this, let me go off to the side here. Right, a square root is a fraction. It's 1/2. So 8 over 2 is 4. So this is a to the 4th. Square root a, b to the 6th. And this is the final answer. Okay. It looks a little weird. I would prefer, the preference people would have is you write it like this, 2a. But you know, this is fine. Okay. So this is something you should be comfortable doing. Okay, just simplify some fractions. Okay, distribute the powers, and then simplify. All right. Another kind of cool example is the square root of x times the square root of x. Right, this looks weird. But if we just, use our knowledge of the fact that these are fractions, it's not that bad. Okay, because then, right, if I distribute this, you get 1/2 times a half, which is a 4th. And so this is x to the 1/2 plus 1/4, which 1/2 is 4 over 2. So this is x to the 3/4. Okay, and that's the answer. All right, so hopefully some of this is not new. Hopefully this is kind of review. Moving on to the last thing. Oh no. The last thing in this section, okay, is rationalizing the denominator. Okay. Okay, so rationalizing the denominator. This is guaranteed to be on your test, I think. So basically what this means is we're going to multiply by something so that we do not get a square root on the bottom. Okay, so rationalizing the denominator means no roots on the bottom. Okay, so really it's kind of easy, so I'm just gonna do some examples. Okay, if I have this, I'm just gonna multiply by square root of 3, and then I'm gonna get 2 square root of 3 here, and then the square root of 3 times the square root of 3 is just 3. And then if you want to, double check if that's true, right, you would do this 1/2 plus 1/2, right? That's just 1. Okay, so yeah, this is how you would rationalize a denominator if it's just the square root. Okay, it gets a little more complicated, not that hard, but like what if you had like over a cube root? How would you rationalize this? Well, if we saw the work, right, you had the 1/2 plus the 1/2, and I got the 1 here. So what you would do here is you would multiply by cube root of x squared. Okay. And then the bottom just becomes x, and the top becomes 25 cube root x squared plus x cube root x squared. Okay. You don't even have to FOIL if you wanted to. You could have kind of just left the top as is. But yeah, no root on the bottom. Okay. Now, really, this section is about these kind of questions, though. So what happens when you get something like this? 2 plus square root of 3. So if I try the same trick, you're going to see it doesn't work. Okay? Because then, if I distribute, I still have a root, right? This 3 popped up. Okay? So this idea doesn't work. Okay, we need to be a little more fancy. And so what we do, okay, when we have things like this, okay, is we multiply by something called the conjugate. Okay. So this is the conjugate. All right, and the conjugate is basically the exact same thing, it's just it has the opposite sign. Okay, so opposite sign. So what happens? So the top just becomes this, okay, and the bottom is this, and you have to FOIL, okay? But you will see something interesting happen. Okay, so right, this 4, then this one plus 3 root 2, just kidding, plus 2 root 3, then this one minus 2 root 3, this minus 3, right? Square root of 3 times square root of 3 is 3. And if you notice, those cancel. And in fact, it'll always cancel. That's like the magic of the conjugate. Okay, is that the inside parts always cancel. So really, all you always have to do is just multiply first and last. Okay. Okay, so what happens? 4 minus 3, 2 minus this, 1. So the answer is just this. Okay. All right, so let's do another one, and then let's wrap up this section. So last example, 1 minus square root 5. That means I'm going to multiply by 1 plus square root 5. Okay. The top is this. The bottom is, I'm just going to do this. So 1 minus 5. So the answer is 1 plus 5 square root 5, negative 4. Okay. And this is just the answer. And that's it. Okay. So just make sure you do this last part, this rationalizing the denominator, especially with the conjugate. Okay. And that is it for section 1.2. Okay. See you guys in section 1.3.